Hi there, and welcome to today's physics class. For this class, we'll be diving into the concept of principle of moment. So, principle of moment has a law, and I'll state the law for you. Aside that, we'll look at the concept of clockwise and anti-clockwise, and also, with having said that, we'll now look at yet several past questions or perhaps examples involved in the study of principle of moment. Principle of moment states that the sum of the total moment about any point is equal to zero. That is, the sum of clockwise moments at any point equal to the sum of anti-clockwise moments about that point. So when it comes to principle of moment, the key word there, or perhaps the key idea behind that, is that the sum of clockwise moments must be is equal to per se is equal to the sum of what anti-clockwise moments by mathematical approach. So from the principle there, mathematically from the principle mathematically from that principle, we said that the sum of clockwise moments that becomes the sum of clockwise moment should be equal to the sum of anti clockwise moment. So from the principle, this mathematical form is got or derived from the principle. So the principle of moment says that the sum of clockwise moments should be equal to the sum of anti-clockwise moments. So that's your mathematical concept behind principle of moment. Having said this, let's look at yet the major mathematical form of moment, because again the word principle of moment, what is moment itself? By definition, moment can be defined as the product of force and perpendicular distance. So I'm saying that moment can be defined as what? The product of what? Force and what? Perpendicular what? There distance, right? So when it comes to moment there, you are simply multiplying force and distance together, and that's all, right? That's all. And basically not just a distance, but what? A perpendicular distance. By the word perpendicular, we mean that force is this force here is at angle 90 degree to the what? There to the distance there. So what do I mean in essence? Let's say for instance, I have a line this way. Let me explain moment very well. Since I have a line this way, pick a point, call here point A and call here point B, right? And I have a force coming down here, call it force F, right? And I'm asked to find moment here. It's easy. What do we know? Moment is what? Force. What's the force? That's F. That will become my force times what? Perpendicular distance. Distance here is what? Distance what? AB. So times what? AB. Why is AB perpendicular? Because this force here is forming a what? A 90 degree to the what there? To the horizontal here, to the what? To the line AB. That is why it's said to be, well, that's why it's called a perpendicular distance. So you're only multiplying the force by that line that's perpendicular to or perhaps attached to the force. As you can see, this is simply the basic explanation I can give for moment. All right, I haven't said this, so let's look at the concept of clockwise and anti-clockwise. Observe the principle in general. There are some key words there you need to be familiar with. So when it comes to principle of moment, the first thing there, or the matrices you need to master, are number one, moment, number two, clockwise and anti-clockwise. That's all. And your concept behind perpendicular distance. So I've discussed about moment, yes, moment. I also discussed about the mathematical form of principle of moment. So let's discuss the concept behind clockwise and anti-clockwise. All right. So then please, concept of clockwise and anti anti-clockwise. Let me like the CW to save space. Anti-clockwise. All right. Please, here's the concept. Let's say I have to explain clockwise and anti-clockwise. Let's say I have a wall clock this way. Let's say I have a wall clock this way. For a wall clock in general, I expect I should have numbers there, right? So let's say I have my 12 as usual. Here is 3, here is 6, and here is 9. So this is my wall clock here. So the direction to which your arrow moves determines if it's a clockwise or anti-clockwise. So let's say for instance, I have an arrow this way. So this is my wall clock, right? And what we know is that wall clock in normal real life sense can never move like this. Never move like this in this direction. What we know is that a normal clockwise real life sense will always move in this direction, right? So from 12 to 3 to 6 to 9 to 12 etc. That's a proper normal direction of a clock in a real life sense. This direction that I just drew out here, this kind of direction is said to be what there a clockwise direction. Any direction of a clock that moves in a normal real life sense, real life application, is said to be what there a clockwise direction. But if the arrow moves in an improper manner, that is, I'm having a clock this way, instead of the arrow to move from 12 to 3 to 6, is now moving from 12 to 9 to 6. Definitely something will happen to the world as soon as possible if clock is moving like this. So this becomes what there an improper manner or improper way of clock moving, right? So we are familiar with clock moving in this form. This form we're familiar with is called a clockwise. Why this form that looks strange is what there is called what there an anti-clockwise. This direction is called an anti-clockwise. Anti-clockwise. So this becomes my explanation to the concept of clockwise and anti-clockwise. So note that when a clock is moving in a normal real life sense, real life approach is called what a clockwise. Why if it's moving in an opposite direction or in a way you will be suspicious about, it's said to be what an anti-clockwise direction. So that's the concept behind clockwise and anti-clockwise. Having said this, let's take few examination past questions and solve together and perhaps see what we get through those process. Welcome back. Let's take yet the first example in the study of principle of moments. So example 1 says, for what value of W would the system be in equilibrium? So the question says, for what value of W will this system be in equilibrium? Right, so the concept here is that I'm trying to find the value of W. How do I get the value of W? By applying the principle of moment. As easy as that. Now, first things first, in this question here, I'll try to take moment at a point. So basically, in the diagram, this point here was not indicated. So okay, let me call this point, let me assume this point is point P. There was not a point P here. I just assumed that this point should be point B. So this point P here, this pivot, I'll try to take moment at this pivot here. So if I'm taking moment at this pivot, it means that W will come to this pivot Similarly, 15 force will come here and 12 Newton will come here. That is, for every forces, they will all come down to what? The place I took moment from, which is point P. So the first task here is to take moment at point P. So taking moment at point P. Now listen up. If I am to take moment at point P, what do we establish earlier? We said moment is what? A force times what? A perpendicular distance. What do we mean in essence? Now look up. Taking moment at point P is easy as first task. Let's identify which one is going in clockwise and anti-clockwise first. Now looking at W, if I'm to move W down to this point P, listen up. Anywhere you're taking moment from, which is this point, you're taking moment from, all these forces should come down there. Now observe my W. If W moves to point P in this manner, please, I'm to ask you, this direction, is it a clockwise or anti-clockwise? Of course, is what there is an anti-clockwise. So W here is what? An anti-clockwise. Let me call it A. A signifies anti-clockwise. I'm done with W. First force. Second force I'm seeing here, it is for one to go to P, is to move this way, right? This direction here to P, what is it called? Is it a clockwise or anti-clockwise? Of course, a clockwise. Let me call it C. This one too move in a similar manner to point P this way. Let me call it what? Is this direction is for a clockwise direction? Let me call it C. So I've gotten the direction to which every force will move to the point I took moment, right? So this one W will move to point P in an anti-clockwise direction. This 15 will move to point P in what there? In a clockwise direction. Similarly, 12 also, or perhaps 12 Newton will move to point P in a what there? In a clockwise direction. Now listen up, please. I am focusing on force, not distance now. Now look up, please. We said from the formula I gave you, from principle of moment, I said that principle of moment states that what? The sum of clockwise moment is equal to what? The sum of anti-clockwise moment. Please, this formula was given to you by the principle of moment. Now let's solve this problem together, please. Now listen, the first is first, let's get the sum of clockwise moment. Please, for clockwise, open your eye very well. I'm seeing C, I'm seeing C. Focus on these two, that's all. Now for clockwise, for this C, this is our first clockwise here. So let's find the moment for this first C. We said moment is what? Force times distance. So if this 15 should move down to P, of course, 15 moving down to P, it means that I'll have 15, which is the first force. Now, what distance from here to here is of course what? 6. So that becomes what there? 15 times 6. Force times distance. That's my first moment for the clockwise direction. The second clockwise direction will move in this manner from here to this point, to point P. This direction is what? A clockwise, I said initially. But what's the force here? That's 12. So I have a plus here, open a bracket, that's 12 times distance from here to this point is of course here to here, which is what there? 11. 11, I have this. So I'm done with what? Clockwise. The sum of clockwise, I'm done with the two. I'm left with what? An anti-clockwise A. So let's focus on anti-clockwise now. Let's focus on anti-clockwise. This is equal to the sum of anti-clockwise. Of course, the only anti-clockwise I have here is just this force here. So this force moves to point P in this direction. Of course, this is W is my force. That becomes a W times distance from W to this P is of course a 10. So I have 10 here. Get this done, please. 15 times 6. Of course, we give 90 plus 12 times 11 will give 132, being equal to W times 10 is what? Give 10 W. Add up this, I'll have about 222 to be equal to 10 W. Of course, I'm expected to find W. Is as easy as divide by W, divide by W. So what will I get here? Of course, sorry, please divide both sides by 10 to get W by 10. So this will cancel this. So I'll have that W will be equal to 222 over what? Over 10. Of course, W will be equal to 22.2 Newton as my answer. So this is how you find W in this particular question. So I've taken my best time to explain the concept of dismount and force concept. So let's look at yet another example in our next class. So do well to like this video, comment and subscribe to my YouTube channel. If it's your first time here, do well to subscribe, very important. And also on the bell icon so you can be notified when I drop any new video. Also do well to reach out to my website at www.ghanaboku.com. In my website there, I have close to 250 video for mathematics, chemistry and physics. So you can do well to purchase them. It's a lifetime access. So once you buy the course once, it's a lifetime access. And also do well to join our WhatsApp group, which I'll be dropping the link in the description of this video. Alright, see you in the next class where we'll look at several other higher examples of principle of moment.